Here's a screenshot of where chat where says Phil says solar panels produce power in moonlight.
Yeah.
I don't know, what does solar mean, guys?
Hello everyone and welcome to a short explanation video that I'm afraid I have to do. Responding to this tiny little clip that was in Flatzoid's original reply to my What is Entropy video. Now the issue is that there were so many little things that Flatzoid said in that video that I would need to do 10 more videos, but I don't have the time. I have an exam in 2 weeks that is really hard. It's about general relativity, by the way. And I have to hand in my master's thesis by the end of the year. And whilst I'm doing pretty good, that still means a lot of stress. So, you know, okay. But I just have to do this video. It's so fun. So Flatzoid says that solar panels can't produce power in the moonlight because apparently solar panels can only produce power when the light comes from the sun. That's why they are called solar panels. So there are so many things that I find funny about this, all of which hint to a fundamental misunderstanding of what light is. So a short explanation of what is light for this purpose and how solar panels work. So light, what is light really? For these purposes, you only need to do kind of three things, kind of only two really. Light carries energy, and it's an electromagnetic wave. It's also a fundamental particle, but that's not important right now. There are only two of these properties you really, like only one of the properties you really need to understand for these purposes here is that the energy of a photon is h, which is the Planck's constant, times the frequency, right? So, already by that, by the way, the energy of a photon is greater than zero, so you can't have cold moonlight. Cold moonlight will, by the way, also violate the laws of thermodynamics. Just a fun thing I thought I'd mention. Something that also applies to light or any wave, as a matter of fact, is that the speed at which it travels is equal to the wavelength times its frequency. That also works for water waves, that also works for sound waves. Obviously, then it's not c, but some other constant, right? Not important. So, how do solar panels actually work? Well, in the solar panels, you have a piece of silicon, usually. And if the silicon, this is just some atom, that's not specifically silicon. This silicon, or like this grid, if you want, of silicon silicon atoms, obviously has electrons surrounding it. And a photon, which is here expressed as gamma, because that's what it is as a fundamental particle. If the photon hits the electron gets knocked out of the atom. There are two different kinds of this so-called photo effect. There's the inner photo effect, where the electron just is flung to a higher state, like there are multiple energy states an electron can have within an atom, and usually they are at the lowest possible state. If they're hit by a photon, they are hit by, they get knocked up a couple of stages, depending on the energy of the photon. And the second thing that's possible is the so-called outer photoelectric effect, where the electron is receiving so much energy from the photon that it is shot out, if you will, completely from the atom. And what solar panels do is they utilize the outer photo effect, which, by the way, Einstein explained the first and received the Nobel Prize for it. So the electron is hit by a photon, and it is flung out of the atom. And now because this happens all the time, because you know there are so many photons coming from whatever your source is, with some clever semiconductor physics, the electrons are being redirected, so they don't go back right away to the atom, but they take a little way around, if you will. And this little way around already creates a flow of electrons over time. Electrons have charge. If you know, then charge over time is a current. So you have a current all there, and you can also create a voltage through, again, somewhat clever semiconductor physics. And with that already you have created power. Now, Flatzoid, that's the part where I would like an explanation. Why should it not work if the photon comes from the sun and is reflected from the moon? on the sphere Earth model, on the globe Earth model, on the heliocentric model, if you will, although that's kind of not its name. Could you maybe tell me on a flat Earth, why wouldn't it all? Why should it work any different? This would even work on both models. If the moon emits light, which it clearly does, and the light behaves according to the laws of physics, which I hope it does, or which I hope you think it does, then those photons too can, if they are of the right frequency, create power within a solar panel. I will link you a video where, or even multiple ones, where people have solar panels out in full moon and they're creating power with it. This can work on both models. This, of course, is how it really is, not to scale by any means, but why shouldn't this work? You can even create energy in a solar panel when you shine a bright enough light on it, like a flashlight. Does that not work as well? Because it's not solar? Because what does the solar in solar panels stand for, guys? Is unhinged. Truly unhinged. How do the solar panels know where the gamma comes from, and how can it distinguish which photon it is? I would love to know if you if you could tell me that. I love your literalism, Flatzoid. It's so funny. We have in Austria a very famous thing that tourists bring home when they have visited Vienna or Salzburg or something, is Mozartkugeln, which are small chocolate balls that are filled with some nougat cream, right? And they're called Mozartkugeln because, well, Mozart is arguably the second most famous Austrian, and the most famous one that we're kind of proud of, right? so do you think in Mozartkugeln, or in Mozart balls, if you will, there's a piece of Mozart? Because that's what you're implying. I love it. I absolutely love it. And also Flatzoid, if I have you watching, or any one of Flatzoid's crew, first of all, hi, thank you for watching. But more importantly, has Flatzoid, or have you solved my 3 entropy questions yet? If yes, I would love to see the results. If no, let me know when you have him. I asked you in a little live stream. Maybe I can cut in the clip.
Olaf says, I thought I asked the examples. Those 3 examples, I haven't even looked at them again. But to be honest, I don't know if I'm going to be able to do it, because you know me and maths. But I said I will try and do it, Olaf. But thanks, mate.
Where you say that you will do it, but you are not good at math, which is fine, right? Although, to be quite real, 2 of them are, well, at least one of them is solvable without knowing anything apart from multiplication and 2 basic laws that apply to how entropy behaves. But yeah, so I would like to see your results. If you don't give them to me by, I don't know, the next 2 or 3 weeks or so, I will then finally post the results. I'm really busy, I'm sorry. But yeah, and with that, it's a kind of a short video, but still something that I had to do because it's so funny. So Flatzoid, yeah, I would love to hear your reply. Maybe write it down in the comment sections below. And so thanks everyone for watching. If you did enjoy this video, maybe consider leaving a like. If you enjoyed it a lot, maybe consider subscribing, or considering subscribing. And I will leave it at that. I thank you very much for watching, and I will see you in the next video. Goodbye!